Right. So, hi everybody. Um, Apologies for the state my hands are in. I had some very bad mosquitoes, and yeah, I got bit. And just a small piece of news: for the first time today, I'm going to feature the cat camera. Hi guys. Hello everybody. So this is Pesto, and she's become a giant. This is actually a Sony Trinitron display. It's a 46-inch model, and I'm also a giant now. So, came for the tube, stay for the cat. Well, what were you expecting? Hi from Portugal again. I've never been to Portugal. I heard it's a very nice country. The cat's name is Pesto, and she is very sound asleep. Like, I wish I wish I had a lapel mic because you could hear her snore, but now I can't move the microphone close enough for you to see her. Well, let me just before I start the actual stream for another couple of minutes, you can enjoy a cat in glorious whatever this is, 720p. So this is Pesto. Yeah, apparently the Soviet electrometer is winning. Look at the feeties. Yes. Only had one cat which snored. Well, I have 4 of them and they all snore. She is, I think she's something like a Norwegian forest cat. She's very, very fluffy. Yes, and the lighting did improve a lot. Thank you very much. The quality of stuff has improved through investment. Okay, so the Soviet electrometer is winning. I'm just going to give it another couple of minutes to see what it's going to end up like. And then we can start. Pesto the kitty cat. How's everybody doing? Tomorrow's Monday again, sadly, but happily. For me, happily because hopefully next week is gonna be when I get my 3458A. 4 cats and a dog, I forgot to mention. And they are all... Yes, that is a micro CRT. It's not a micro CRT, it's a mini CRT. It's a Soviet 6L0 something something. Well, she's only like 6 months old, and I got it. Actually, I got a spot to form on the screen. It needs about 1,000 volts on the anode, and it's got a 6.3 volt filament, and it's electrostatically deflected, so it's suitable for like a small portable oscilloscope or something like that. I think that was the main application for it previously. Okay, so I'm gonna put Pesto here in a corner. Because I don't think she'll move that much. She's very sleepy, and when I have some detail to show you, I'll just move the camera a bit and the small one, and I'll bring you in closer for a closer look. Because I find it very hard to zoom in with the overhead view, and I think it's a better approach. So the Soviet electrometer won. Oh, thank you for snacks and stuff. Again, thank you for the donation. Cats are gonna. Cats are, by the way, they all share 4 food bowls, and they are very picky about their food, so they'll only eat from the the one that's filled the most, and so they crowd along close to the pretty small bowls in which I feed them, and they empty one and then they move to the second fullest one. You'll get to see the BNK, and then they empty them progressively, because the tendency of a cat is to always eat from the biggest pile of food. Right, so yesterday I went to the flea market, and so did I today, and I got way too much stuff. I don't think I'll have enough time this evening to show all of it to you. So let's start with the beginning. X marks the spot, and I know it doesn't look very interesting from the top, but if you'll allow me, because people have been screaming at me that I'm not using gloves for stuff like this. This is the electrometer head of a, I think, let's see, VK2-16 electrometer. This is the V something something -1 is just the electrometer head, and it's been thoroughly cleaned. Like, I degreased it with IPA, and it's been very, very extensively cleaned everywhere. I actually have two of them. One of them is going to a dear friend of mine, and not this one. This one I'm going to take apart and probably ruin in the process, but Razvan is getting the other one. And I didn't know exactly what it was in the beginning when I first saw it, but if you look around here, Pesto's also very curious, there's a 100 picofarad written there, and then we have 10 to the 8th ohms, 10 to the 10th, and 10 to the 12th ohms. So that's tera ohms basically. And I immediately thought about electrometers. Yeah, VIB1. No, I'm not Gearco reps. No. And this is just the electrometer front end, and those resistors and that 100 picofarad of capacitance are responsible for the feedback. And this is a very interesting capacitor because it's a dynamic capacitor, or as it's also called, a moving reed electrometer. So basically this is the business end. This is the connection to the outside world, and you'll be able to see that there's a orangish colored insulator in there, which is actually amber, as I heard. Amber is fossilized tree resin, so very arcane and exotic materials used in the construction of this thing. And then we have a multipole connector, which I have the cable for, and this would go to a base unit which had a display, a moving needle display, and it had a power supply and a driver for the dynamic capacitor and other stuff like that. So I'm going to start by taking off the bottom first, because that's easier to do, and I picked the wrong screwdriver, of course. Wait, I came prepared. Oh, and by the way, it's using this, from my understanding, which is admittedly not great. It's using this thing. I think it works. It's using this principle, like, of the moving reed electrometer thingy in order to compensate for temperature drift. So what basically happens is that you have a capacitor which has one of its plates made out of basically a vibrating reed, which is driven by a solenoid electromagnet basically. And the charge on the capacitor stays constant, but by moving the plates diameters closer one to the other, you change the voltage on the capacitor, and it acts like sort of a chopper in the same sense as a chopper amplifier. And that's how you auto zero basically, and you ignore temperature drift and etc. So that's the very dumbed down version of the function of this instrument, because I honestly am not confident enough to make any claims that I know what this thing works, how this thing works more than what I've told you. So inside here, I'm gonna put the cap back on. I'm glancing over at the other display with the chat because I'm watching OBS on the main screen, and let me just get rid of the small camera for the moment. Right, so what we have here is basically we have the vacuum tube, which is there. It's in that foam thing which is falling apart. We have pesto, of course, and the dynamic capacitor. Dynamic capacitor is in the middle of this structure here, and we have some components along the sides, some resistors and capacitors, and I think even a couple of transistors. They're probably there to drive the coil in the dynamic capacitor. By the way, I don't guarantee this thing will ever work after I'm done with it, because the cat cam, sure, wait a second. She just took her place back. Right, I am gonna try and take apart the dynamic capacitor as well. Lignum vitae, living wood. What is it used for? So, yeah, that's basically how it works, and I'm going to take it apart a bit further using my flat blade. Apparently, screws were made by high school students or school kids, basically, in shop class back in the Soviet era. And that explains the poor quality of most of the screws that I've seen in Soviet equipment. And it's got a rubber sheath on it. So this is the dynamic capacitor, the heart of the instrument. By the way, this thing has a resolution of a couple of AttoAmperes or something like that. The accuracy is 3 AttoAmperes, if I'm not mistaken. Anyway, it can measure down to some ridiculous currents, like way better than my 617. And it's doing that with a vacuum tube and without any matched JFETs or any stuff like that. So it's very, very impressive. Okay, let me get a thing to unscrew the top off of here. And we can use this, I hope. Yeah, that works fine. Yes, they did. Same screw design for everything, basically. I don't know what was up with that, but... Alright, so we have the duck's guts, the dynamic capacitor. Let me actually take the camera from Pesto's face and try and get you a closer view of this thing. I'm not entirely sure if it's going to focus. Wait. Now let me zoom in a bit with the other camera. Right, so you can see the moving plate, I hope, if it would focus. I'm very tempted to say AV's catchphrase when it comes to focusing, but I won't. Yeah, wait a second. Here, have Pesto back. It's not gonna work with... Thank you for the compliment. Dual cam is a nice idea, as long as you can get it to work properly. So as you can see, I have two cameras, neither of which will decide to focus when I need them to. Oh yeah, you can see it now, totally. And you also get a cat in the side of the... Okay, so we can see the two plates on either side, and the inner one is connected through this amber dielectric to the top of the device. So basically what happens is there's two electromagnets on one on each side, and I think there may be more. I think there's actually 4 of them, and these electromagnets only serve to close in and spread apart the outside plates of the armature from the inner one, and that does the thing with the charge remains constant, but the capacitance varies, so the voltage must vary. So that's all about the dynamic capacitor. Let me put this back together-ish. I don't want to completely ruin the thing because... Oh, and this was built in 1977. So 1977. I don't know off the top of my head anything interesting that happened that year, but I'm pretty sure this comes from Minsk because I've seen several other people who've talked about this device, and they say it comes from the Minsk Institute. 1977 was Star Wars, really? This is for sheer salad. Love the name, by the way. This is a moving reed electrometer head from Soviet Russia. Okay, oops, you didn't see that, I hope. Made a fool of myself, but let me just put this thing back inside. Wait a second. Right. And now we can take a look at the top, which is equally beautiful. Actually, even more so. I'm sorry you're gonna see my hands for a while. Here, have some more cat. By the way, I love these WIA Ergo Star screwdrivers. They have twin ends. So you have a couple of sizes of several types of drivers, basically, and you can adjust the length very easily, and it's extremely nice to use. I've had this set for about 5 years, and it's worked great. There's one catch. They're made out of, I think, S2 tool steel or something like that, and they don't like to be shocked. So if you have something like, I don't know, don't put them in power tools, because somebody did that once, not me, and they busted the top of one of those ball end hex drives. Dedicated cat cam. Hello, mate. Jesus. Whoops. We'll set this aside for later, and we shall take a look at the good bits in here. So we have one of those nice Bakelite military-ish connectors, and we have the selector ring for the feedback resistors. And I'm gonna try and show you inside, but it's gonna be very tricky because there's not much light in there. Hopefully. Wait a second. I need extra light. No chance in hell am I gonna get that. Let's see if we can take it apart the wrong way, and so I can show you what happens when you actually change the feedback resistor setting, basically. Whoops. Pesto's now sleeping on a tiny CRT. And this won't thread, because why would it? Right. Okay. This does come from my regular supplier. So it's first this bundle of joy here. And funny thing, CRT cat rest tube, exactly. Funny thing here, this hole pattern is 8 holes, and it's not symmetrical, so the holes aren't spaced with the same number of degrees between them, and that's so that it will only fit in one orientation, which is very frustrating when you're trying to assemble a very fancy and high-end instrument, and you're trying to figure out which way it went back together. Ask me how I know. Right, I think that's this removed, and now we have to take this apart, the selection ring. Okay, and now this will spin freely, which enables us to then switch to a flathead, remove this lock grub screw here, and I'm gonna keep the poll rolling, so the second most upvoted thing will be next. And we're into the finer details now. Look at that. So this is just another amber dielectric with, I think, some phenolic or cork maybe even, I don't know exactly. But this is where the pretty stuff is. And if I can figure out how to take this out. Oh, I can actually show you the cool thing that I meant to show you previously. If I put this screw back in, hopefully this is the right one. There's only a couple of Phillips head screws on the whole thing because I don't know why. Wait. Apologies for the lack of focus for the moment, but now if I twist this, can you see the spring, the needle popping in? Now it's going to change to the next one, and the next one, and the next one, and the last one, and all the way to the back, and they're all disconnected because this is the default position, so this is when nothing is connected. But for the moment, let's just set this down like so and have a closer look, and I do mean closer. So hopefully we'll focus. Okay, I think that's acceptable. Can you see it properly? I think it looks good. So let me get the pointing thing. So I got sushi especially for this. So what we have here is the connection for the feedback, which is made either out of a couple of these resistors. So there's, I think those are gigohms. This is an 820 gigohm resistor. Yeah, exactly. And there's a couple of more values behind it. So I think there's 820 and another 20 gigohms. Exactly, precise current measurement. It's not about precision, it's more about the order of magnitude of current that you're trying to measure. I'll do a recap afterwards of the entire thing when we're done with it. So these are vacuum sealed resistors, which are crazy. I have some, and I think I showed them previously. These are American Victorine resistors. This is just a measly 10 megohms. But I do have a 100 gigohm resistor somewhere around here. Like this is 100,000 megohms, which is 100 gig. But this one is 820 gig. So this symbol here, I think, is a G because I recognize it off of like a GU30 or GU81 tube. Yeah, this is the electrometer. And if you look here closely, this is a capacitor. It's an air capacitor with an amber dielectric, so incredible. Everything is stuck on amber isolators, so everything you see orange is amber. And apart from amber, the only other isolator is air or glass for these resistors. So these resistors are actually, I think, they're, yeah, okay, so it's a gig, yeah. 820 gigohms plus minus 10%. So it's either 900 gigs or 700 and something gigs. It's not very precise, but it doesn't matter. Oh, and this is very nice Teflon coated wire. I have a reel of it somewhere, but it's a nightmare to solder and tin because not only it's Teflon coated, but it's also cross wound with something like silk, so very, very fine silky substance. And let me just try and figure out how to take this thing off. And I want to show you the actual selection mechanism inside, how it actually works. But I don't think I remember how to do this exactly. Oh yeah, I remember now. So can you see these two slots here? Those are for a giant flathead screwdriver with a cut in the middle to unscrew this thing. Alright, and if we take this out carefully, and keep the ball bearing in place, because there's a ball detent in there, we can see the rest of the thing. So the way they did the thing with the clicks is they just had a spring preloading a ball bearing. Yes, Cyrillic was based on the Greek alphabet, and it was written and devised by two monks called Cyril and Methodium, Kirill and Methodiu. And they decided that they needed a better alphabet for the Slavic people, and they kind of moved around the characters in the Greek alphabet, and then we got the Cyrillic alphabet. So Cyril, Kirill, and Methodiu, the two monks that devised the Cyrillic alphabet. If I'm not wrong, that's a story I heard from my grandfather a while back. He's a linguist, so if anybody was to know that, I think it would be him. So yeah, amber is apparently as good or even better a dielectric as sapphire. As good as sapphire, or even better than, sorry. And apparently it's harvested from around the Baltic Sea. So it's crazy. I'm not entirely sure what, because I've seen Soviet equipment and I dropped a washer and it's gone forever. It's in the third realm now. I've never seen, I've seen other Soviet electrometrology with sapphire as insulators previously, but I've never seen amber till this point. So people go to great lengths when they want to minimize leakage currents. So I'm just shifting things around a bit in order to make some more room for the next item on the list, which should be there can be synthetic amber. So synthetic amber is a thing, but I'm not sure if this was synthetic or natural amber. Right. Okay. Let me just check what the second most voted thing is. It's Mishmash. Okay, we can do a quick round of Mishmash, and then we can take a look at the vacuum tube stuff that I promised, and then the Brule and Care. I'll leave the Brule and Care for last because it's by far the biggest, heaviest, and craziest thing I found these days in the flea market. By the way, chat, no, I'm not from Russia. No, I'm from Romania. My people were under the Russian boot for decades, and there's a joke around this part of Europe that says that there's nobody to hate the Russians as much as the Romanians and the people around them. I don't have anything with the Russian people per se, but I'm not gonna go into more politics because of the situation. Right. So, Mishmash. Okay, let's look at some Mishmash. Took off my gloves because my hands were getting sweaty, knees weak, arms are heavy. Right, so this I got from the same guy, and it's a RF amplifier. Hi, Vinny. RF amplifier for something like telecom or something like that. And I should have taken the screws out before doing this. I'm doing my best. By the way, remember the not to derail, but what watch is that? It's a watch. I'll leave it at that. It's my birthday present for myself, from myself, a couple of years back, and I saved up a lot of time to get it, and it's Swiss made. I think, yeah, it is an Omega Seamaster. It's the Aquaterra. So this is a RF amplifier for something like telecom, and it's absolutely beautiful. So we have, I think, several stages of gain, and I don't know what this device is. I think it's a power amplifier too. I would be surprised if, I don't remember, this was the output, so it was in and output. So thank you. Yeah, yes, they are ceramic PCBs. They use ceramic PCBs because of far lower dielectric loss and other parameters that affect high frequencies. So actually, if you think about it, when you have a transmission line, the energy of the signal isn't in the conductor itself, it's in the dielectric. So you need a very low loss dielectric in order to make sure that your impedances are matched, everything is fine and dandy, etc., etc. And these are some funky looking components here. I think these are actually inductors. I'm not entirely sure. They might be very, very... Oh yeah, stupid. I think they're the biasing inductors. So each stage requires a biasing, a bias T in order to bias the power, the active circuit. So this is actually, so this is a bias T for this stage, which is probably a low noise preamplifier, and then we have 1, 2, 3 stages of gain, and then finally the power amplifier. This doesn't have much gain, but it has, I think, no, it's not from Rohde & Schwarz. I think it's 4.7 microhenry. It might be, it's Italian. Whoops. Come on, focus. Wait. And of course it's backwards. Just a second. Apologies. For those playing along at home, It's Unità Amplificatore TX, transmission amplifier unit, part number, you can see there. It wouldn't make sense to be a circulator. I have no idea what the bandwidth and the frequency is. I think it's for, what do you call it? I think it's for telecom. Bias should be the yellow wires on top. No, actually no, because if I take the bottom off, and I'll do it right now because you guys deserve to see everything. I really love my viewers, by the way. I know that people don't hear that they're loved enough, so no, they're not RF transistors. I'll zoom in and show you. Thank you. I appreciate it. I love you too, guys. It's military. Oh, whoops. You didn't see this. It doesn't make it doesn't make sense for it to be a circulator because the signal path doesn't warrant it. So there's no need for circulators and just an amplifier. My intuition with them being bias tees is the fact that if we look at the back, if I can take this thing out, come on. I'm gonna go all Bill Burr soon and start saying Jesus. Okay, if we look at this, so pin might be a pin diode. So it might be an input switch, for example. Then we have VGS1, VDS1, VGS2, VDS2, VGS3, VDS3, VGS4, VDS4, and P out. Power, no, that's power in, power out, or P in, P out. Pin diode switches, maybe. I'm pretty sure they're pin diode switches. And VGS and VDS refer to, evidently, the drain source and gate source voltages of hi Stan. So those are biased yellow ones. They're, let's put it this way. I think the bias, you know what? Chicken butt. You might be right. I have no idea. From what I can understand, though, this is the drain and the source of a MOSFET, the drain and the gate of a MOSFET. So the source is tied to ground. These are all, should be all common source amplifiers, I think. Might be wrong. You design such things. Okay, so I have no idea what I'm talking about. I told you guys that I don't know RF. Maybe they're filter inductors. I don't know. They don't look like circulators. There's only 2 terminals on them. And don't make me take out the impedance, the LCR meter, to see what it is. I can actually take out a multimeter. And let's see. So I'm gonna measure. So it's 0.3 ohms across this. So that's pretty much a dead short, and it's an inductor, I think. And this right here, wait, is also a complete 51 ohms, which is a termination resistor. That is correct. If you don't believe me, wait a second. I hope you can see. I'm trying to do this through the camera. And so this is 0 ohms, and if you go from here to here, sorry, 51 ohms. So terminators. And these are, let's look at the part numbers a bit closer. I don't think it's ever going to focus that close. Anyway. They're all Mitsubishi parts, so 104450A, I think, maybe. All right. Maybe it's a circulator. Okay, so let me just zoom out again. And just a second. Let me clean out the nuts and the washers out of everything. And I don't know where to put them, because of course I don't know where to put them. I'm just gonna put them here. And I'll try and remember to put these things back together. I have no idea what gain and power this thing is rated for. I don't want to really take it apart because I might use it. By the way, the cat camera is still up, guys, if you want to look at her. She's right here. And look at them feeties. The jelly beans. She's very tired. She's had a long day being cute. It's very hard to be this cute. Yes. Toe beans. Yes, exactly, toe beans. Right. What was next on the poll? Let's see. Old vacuum tube stuff. Old vacuum tube stuff. Let me just reach out and reach down underneath the desk. Move the cat a bit further to one side. And no, it's not. Might use it means that I might use it. It doesn't mean that I'll just put it somewhere and forget about it. I also love my ADS 200, and for what it's worth, it's the best soldering iron I've ever worked with. Right. Jesus. And the obvious question is, where the hell did he pull that thing out of? Well, I pulled it out of another cat underneath the table. So let me try and see if you can hear this. Can you hear that? That is I think the same kind of device that was in the electrometer, just a bit less refined. So I think that's a chopper as well, some sort of chopper, electromechanical chopper. Let me try and take this thing apart, expose it. I also heard that the RF heated Metcals are very good, but I've never worked with one. I have a coworker who has one, and he swears it's the best thing ever, and he says that although it's only 60 watts, it heats up very fast and it solders everything. I can't believe it's as good as the 120 watts of pace, but so if you were here last week, I explained that pH meters are basically voltmeters, but they're very high impedance voltmeters. Actually, wait. So this is the pH meter I tore apart at the on the past stream, and I'm gonna do a quick recap. So basically, what we had were two op amps in. I'm pretty sure that they have this bridge diode limiting for the output or something like that. And it's just a regular unity. I think this one is a transimpedance amplifier due to the resistor and the but actually no. So it's a unity gain buffer. It's got a very high impedance input. This is a very, very low bias current operational amplifier. And pH is the negated logarithm of the concentration of hydronium ions in a substance. And pH probes actually have two solutions, potentiostats. It's an electrochemical cell, exactly. Yeah, to put it bluntly, it's an electrochemical cell. The electrode has a porous membrane that can pass ions, and it can generate a potential difference between two electrodes. Apologies for the grunting, but this thing is very heavy, and it's nowhere near as heavy as the Brüel & Kjær. Yeah, tips for the Metcal and the Thermaltronics are very, very, very expensive. The tips for the Pace are about $10, and the base station for the Pace is about $350 or something. That's how much I paid when I got it. Exactly, they have a working reference and a counter electrode. You know a lot more about these apparently than I do. So guys, what do you want to do? Do you want to just take a look at this, or do you want to see it completely torn apart bit by bit? Because I'm not sure I can do the second one. There isn't enough time in the world. Let me just have a sip of tea. Cheers. Cat and mug for scale. So I did turn it on, and you can hear it humming. And after a short warm-up, we can look at the very nice corrections for various things. This is a 0 of some description. There is a button that says measure, and I think you need to tweak stuff to get it on 0. And why I stand by my claim, yeah, exactly, it's an it's from the GDR, yes. So if Stan said that it's a glass electrode which allows sodium ions to move within the glass, and then a silver chloride reference, well, he's gonna be a doctor in chemistry, so yeah, he's probably right. So this thing was made in Dresden, and I don't know if you know about Dresden, but it looked like Dresden in 1945. Dresden was very severely bombed. And it can measure either 1400 millivolts, 700, blah, 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 or a 0 to 4 pH scale, or a 0 to 12 pH scale. Well, it reminds me of the joke, damn girl, you're a 10 on the pH scale because you're basic. So this is basically just a glorified very high impedance voltmeter, and it kind of sort of works, but you can see that me just touching it does stuff to it, because you know, this doesn't come from Dresden. This comes from Bucharest, by the way. You did an internship in Dresden. What's it like? Right, so let's have a look. First of all, let me move the, let me make the cat picture a bit smaller so you can see the rest of the controls. So we have the fuse, the on-off switch, polarity. This means external. This is earth, and the very clicky, satisfying range switch, basically. And if I, first of all, I shall unplug this thing because I love my life and I still haven't seen my 3458A and I don't want to die. And Probably YouTube is going to take down my stream if I die on stream. So first side, the bottom side, we have some very, very nice looking potentiometers. Let me just, I had to take off my glasses because they're not for what I use them. Potentiometers for setting the various things, and the very clicky range switch. And there's an interesting design thing I'll show you a bit later about this range switch. It's very mechanically complex, more so than I would have thought initially. And I'm just going to set it on its face like this and take out these 4 screws and have a look inside at the circuitry. By the way, I think these are precision resistors. They're precision resistors, but precision. Because what this thing is, basically, it's also kind of like a bridge circuit of some description. And what we have here is some, I think, quite fancy capacitors. I think these are capacitors because they sure as hell aren't resistors. Yeah, so these are resistors, 800 ohms. This is a precision sealed RFT part. It's a precision capacitor, very, very low leakage. And for example, this is a 10,000 picofarad, I think. Anyway, I don't know exactly. This is an electrolytic, and we have 2 vacuum tubes here. 2 pentodes, EF86, both of them. Precision. Yes, fancy, hermetically sealed. And we have 2 pentodes. Pentodes are very good for high gain circuits with relatively low noise due to the fact that they have extra grids inside which suppress secondary emission and stuff like that. And we have another cute thing here, which I'm going to extract and show you over the top. 00H25. This is a Pressler. If you've seen my past videos, especially the one with the high-speed camera, you'll remember that I pulled a Pressler tube out of that one as well. This is a gas discharge voltage regulator, I think. And Stan loves EF86s because EF86s sound good in guitar amplifiers, don't they? All right, so let me see if I can put this back in. Okay, let's take a look at the top. Nice retaining cap. We have the 2 EF86s, and we have the input and the power transformer and my kludgy wiring that replaced the original wiring for the device. Let me turn it on to this side and we can see, come on, focus. Okay, it focused. Stay focused. Focus, Danielson. We have the 2 switches, and you can see another very interesting design choice for the switches. So you can lock them in a position. So for example, if you want to do a continuous measurement, and you can lock them in both positions, and when you push it in, it contacts that thing and starts measuring. And when the spring should have returned it, but the spring has gotten a bit weaker over the years, and I find it very interesting that you actually have to turn the switch in order to lock it into a position. For me, usually switches are just depressed, not rotated. But Okay, good night question. Take care of yourself. Get your 8 hours worth of beauty sleep. And see you next time. This is the switch, the main power switch. This is the polarity reversal switch. Taps for selecting the voltage for the transformer and the wiring to the transformer. And this is the other cool thing that I wanted to show you. If you look at the range switch, you'll see that at some point two cams pop up and they contact the upper segments of this switch. Let me move it in a bit closer. And can you see it? The cam engages when you change from pH to voltage measurement. It just engages those auxiliary contacts. And so tube guitar amplifiers aren't just audio foolery, because tube guitar amplifiers aren't meant to run clean. Regular audio amplifiers are meant to have a very flat-ish frequency response between 20 hertz and the 20 kilohertz everybody claims to be able to hear, but we can really only hear about 16K. And frequency flatness and low distortions, and it's stuff like that. Guitar amplifiers, on the other hand, are never really meant to run clean. They're actually so a guitar, basically an ideal electric guitar would have almost no harmonics. So when you pinch a string, it would be almost a perfect single tone. But if you've ever heard a guitar, an electric guitar, you'll see that you'll hear that it sounds very, very gnarly. If you're like into rock metal or stuff like that, that comes from distortion, and that comes from stuff like cold cathode clippers and overdriving, asymmetric clipping and stuff like that. And tube amplifiers, due to the way that vacuum tubes go into distortion and go out of distortion, so overdrive and returning back into their normal operating region, add a lot of harmonic content that is pleasant, whereas transistors would clip perfectly flat and introduce infinite both even and odd order harmonics, which sounds terrible because that's what they do. So vacuum tube guitar amplifiers are the way to go, really. Like, I have 4 of them or something like that, and I regret buying none of them. And the last thing I wanted to show you about this device, and maybe we can see it from somewhere. Oh yeah. Here underneath the vacuum tubes is, I think, a chopper. This is the thing that buzzes. So this is the thing that buzzes and chops the input and does basically kind of the same thing as the Soviet electrometer does. It is achievable with the same solid-state component. So guitar distortion can be achieved with solid-state distortion, as witnessed to the fact that there are modeling amplifiers and cabinet simulators and stuff like that. But I don't know. We just like the sound of guitar amplifiers, tube guitar amplifiers especially. Right. Okay, I'll take a quick break from taking stuff apart because I need to put some of these things back together before I lose track, and I'll have a Soviet pH meter and cat with a CRT up its bum, and yeah. Okay, so I'm gonna just put this thing back together. Let me zoom out so you can see what I'm doing. Whoops. And then we shall talk about some more mishmash, and then I'll talk about the Brule and Care. That thing is gonna be a bear. I'm actually considering doing a separate video about it, but hey, I got you here, guys. And how many of us are there? I'm curious. How many people are on the stream? 11. Okay, that's good. I appreciate each and every one of you coming and joining me for and witnessing my slow descent into absolute madness when it comes to buying far too much test gear and old stuff. Let's see. Whoops. Luckily these are magnetic. Come on. I'm trying to not move my head around too much because, you know, the microphone is relatively stationary, and well, yeah, but there's such a thing called finite financial resources, so, you know. Let me deal with this. So, as I said, if all goes well, hopefully by next week I'll have my 3458A and we can do some work on that, and I can start to yeah, massive wish lists everywhere. I have a wish list for every store in the world, I think. I can start working on my master's thesis more and start ordering PCBs and finishing devices, finishing designs, and start doing some actual writing code, and maybe we can do some videos about that as well. I'm not very good at code though. Programming, not the best. This thing is going in crooked. Volt nut nirvana. Yeah, well, there is not much more volt nut nirvana than the 3458A. I mean, 8.5 digits. What could you want more? Okay. Yeah, you kind of have to be able to write code to get into engineering. I never said that I can't write code. I said I'm not just very good. And when it comes to 9.5 digits, I'm pretty sure that there's some physical, you know, unavoidable stuff that can't be. I know you can do 9.5 digits with resistance. You can do 11.5 digits with resistance. But you know, Jesus. All right. I said more mishmash. Let me find some more mishmash. Oh, I know. Okay, let's plug this thing in and attempt to plug it in. Where is the outlet? Oops, Can you guess what this is by the looks of it? Like from the top? Come on, it's pretty easy. I actually put it the correct way up. It's a Romanian made digital multimeter. It's an E0302, and I think the Nixie tubes are being overdriven quite a lot. But you can see I actually tried it. It's very far off. Like it shows 9.2 volts instead of 9, etc., etc. No, it's only 3.5 digits. So we have 1, 2, 3.5 digits. This is up to 2. Exactly. The first one isn't a +1 or something. It's just a plus or a minus. And I think it's based on single slope ADC or something like that. It's very, very basic, but it can measure volts, current, AC, DC, and resistance. So just about everything you need from a multimeter. So let me show you a few of the interesting things that I found in this multimeter, which was made in Romania. It's an IMEI, so it's the Institute for Electric Measurements and stuff like that. It's not auto-ranging, as you can see. We have a range switch here, and yeah, you can see the digits counting up and down. It's actually working. Oh, you can see it better now. That's a very poor choice. That's a very poor choice of a screen, a plastic screen for the thing. I'm not entirely sure it makes it more visible. On the contrary, I think it makes it harder to read. I do appreciate it, and you have to remember the fact that I also went to the same 4 years of Romanian university hell. I have seen Banderson, what it was, the guy, the poor guy who took his own life. He did a video about the first digital voltmeters and an electromechanical comparator, indeed, and it took about 5 or 6 seconds to display one reading. So sadly, he took his own life because he fell into a very bad depression, and he couldn't get the help he needed to get out of it. I think it was Aussie 50, if I'm not mistaken. Right. So, which view do you prefer, the cat cam or the overhead? Let's do a mishmash first. Let me show you a bit of from the side. So I think this is the actual ADC part. I'm not entirely sure. There's some very not socialist components here at all. These are spectral potentiometers, which I find very, very funny. And you can see them surrounded by a giant, massive, hideous Romanian-made resistors and capacitors and transistors made at IPRS Banasa. They're not hideous. They're the best that Romania could do at the time. Like, we didn't have the resources that other countries did. These are electrolytic capacitors. We Romanians didn't put them in metal cans. We put them in plastic cans, so when they blew up, they couldn't be turned into bombs. That's a joke, by the way. And on the other side, we can see a depraved bougie Leclanché capacitor. Does not beat the Yugoslavian components. I don't think I've ever seen Yugoslavian components. This is a French capacitor, and yet again, loads of spectral parts around here. Um, these were ceramic capacitors. I think these were pretty common in the Soviet bloc. We can see some Teflon. Like if you look here closely, there's some Teflon standoffs. So this node was pretty low leakage. Well, not anymore due to the years of dust and neglect and stuff like that. I should turn it off. And if we take a look at the top, let me see. Let me just get rid of the large image here and zoom in on the other one. I'm really digging this twin camera idea. I'm very happy that I thought about taking it out, taking this thing out of storage. So that's the EOS M200 filming the Logitech. So this is the tiny cam and that's the big cam. And yeah, so what we have here is basically the display drivers, and as the first one is just a plus or minus sign, you don't need a display driver, you can just use two transistors, and this one can either be a 0, 1 or a 2, so yeah, you don't need another. Oh, funny thing, these are Fairchild 74141 drivers. These are the BCD to 7 segment, I think, decoders with the 150-ish volt tolerant open collectors. So these are very desirable components because they're very useful for Nixie tubes, Nixie tube clocks and stuff like that. And yeah, and I think we have just a regular counter and some stuff like that, shift register maybe to shift the data into the. It's very similar to the very old Keithleys. I think this was basically copied. That's another fancy. What was the term? The communists were using a very particular term for Western ideals and stuff like that. Anybody else from Romania who can remember what I am thinking of? There was this term, a pejorative term relating to the depravities of the capitalists. So this is a depraved capitalist potentiometer, and so are all the spectrals, but you can still see that only the depraved capitalist potentiometers were really good enough to be put in this fine piece of equipment. And as we're still in mocking, I love the power switch. Let me just bring you in for a closer look. So the power switch is just a regular toggle switch, but in order to make it look fancier, it's connected to a shaft with a sort of pawl-like mechanism that just toggles the switch. Like this switch would have been perfectly fine just mounted on the top and make it a push button, but no, they had to overcomplicate, the mechanical design and make it less reliable because this thing was so loose that it was almost falling off. And yeah. Yes, depraved capitalist should be a filter on DigiKey. Yeah, I agree. And let's look a bit at the bottom side of this thing. Let's look under the hood here. And we can see the bottom of the... I do have a couple of the 155 ID1. I remember a funny story about, for the rest of you who didn't read the chat, there were the K155 ID1 drivers for Nixie tubes, which were very similar to the 74-141. And I remember somebody explicitly told me that they weren't actually trying to make Nixie tube drivers, but because their process was so bad and their, I don't know what, oxide thickness or whatever was so large and their feature sizes were so huge, their withstand voltage basically was high enough to enable a very high voltage. So I don't know if it's actually an improved version of the 74-141, because if, to my mind at least, I think if you have all the outputs switched off, it's gonna pop. So you have to have at least one output switched on a 70 on a 155 in order to have it not explode. We have some fuses here, which are the fuses for, I think, the current ranges or something like that, AC voltage and AC current. AC current and DC current, and this is for the higher range of DC current. So it can do up to 1 amp. 1 whole amp. So yeah, probably and there's a shunt resistor in there. I'm not gonna do the Medi voice because I've started not liking that guy very much. Shunt resistor here, and those components are also capitalist depravities, and yeah. So you can see that even in a completely hermetic state and with Ceausescu's idiotic ambitions that of producing everything locally, we still needed import stuff in order to have anything work. Oh, and that's the inlet, because of course it has to be special. And a half amp fuse for a multimeter. Right, let me put this down and let me have another sip of tea and a short break, because I've talked quite a lot. And let me mentally prepare for the nightmare, which is trying to get that thing on the table. Actually, I'm gonna do some micromanagement for a while and just put this thing back together. And it went this way, because if I forget or ignore it enough, the boat anchor is incoming. The entropy will soon take over everything and leave me a depressed mess due to the fact that, you know, there's far too much stuff going on around here. So chat, how's everybody doing? Oh yeah, right. It had both Phillips and flatheads, because why not? How's the weather holding up? It's getting really cold here, and it's getting really cold here, and I'm expecting that soon I'm gonna need an umbrella to go to work. Yeah, the UK is always cold and wet, especially when I get there. Especially, actually, on the contrary, every time I've been to the UK, I've never seen a drop of rain. And I've been there 4 times, I think, by now. And every time I've been there, I've had perfect weather. And you're in Idaho. Wow. Ankara, Turkey. Nice. Um, Idaho. I don't even know where to put Idaho on a map. I know where Ohio is, but I don't know where Idaho is. Uh, 18 degrees C in northern Italy. North part of the western side of the US. North part of the western. So near Seattle, that way. I also associate Idaho with potatoes. Exactly. Oregon, Washington, yes. Okay. Okay, so I was pretty close. Uh, to the east of them, they're the neighboring states. I'm familiar with the east side of the United States, his geography, not so much as the west side, so uh, I want to go there at some point. I really would like to see. We have a phenomenal number of potatoes. I remember the guy with, I have potato blood in my veins. Um, yeah, I, rem- I remember that. I remember talking to somebody who actually went to work in the United States as a potato farmer for a couple of years, and I remember asking him, "Well, where did you go?" Idaho. Potatoes, I think of Ireland. Well, not since the Great Potato Blight. No, not since then, pretty much. Um, Lest I lean into the stereotype too much, I grew potato this year for the first time. Well, potatoes are very good for you, actually. They're very nutritious and they're so versatile, so you can do any kind of dish with potatoes. Honestly, I'm a mashed potato kind of guy. Apparently, potatoes are so freedom fries. No, no. Those are Belgian. They're not freedom fries. And the Americans named them freedom fries, and everybody knows this. The Americans named them French fries because they didn't know they were in Belgium. They thought they were in France. Idaho's highest export is microchips? What, potato semiconductor? No joke now, but what companies are in semiconductors in Idaho? I can't find the washers for this one, so it will be washerless. By value, not mass. All right. So it's got to be potato semi. No, not hot potato chips. I haven't gotten my hands on them yet. Micron and On Semi. Oh, really? On Semiconductor. Um they just opened the sort of quarters in Bucharest as well. I think they're doing testing and validation here. There's three big companies in semiconductors in Bucharest. There's onsemi, there's NXP, and there's Infineon. And Infineon is by far has the biggest headquarters here. He did that famous video about potato semi. Yeah, the potato semiconductor gigahertz 74HC something. No, 74G something. He did a ring oscillator, I think, with a inverter or NAND gates or something like that. I don't remember exactly, but those things were pretty cool. Vice President Dan Quayle misspelling potato. How can you misspell potato? Like, there's four, five, there's six letters in that word, and two of them are T. How hard can it be? Also remember the time George W. Bush dodged a couple of shoes heading towards his face. Where did you have maximum ADI? In Ankara? Okay. I'm sorry, I'm just screwing around here while you guys are chatting. Istanbul, okay. Istanbul, I want to go there as well. I want to visit some point. Oh, let me show you one more thing. Well, before we get to the big kahuna on the table. It's going to be very, very tricky. So, what do you think this is? I'll give you a hint. It needs to be very square, plumb, straight in order to work properly. No, not the leveling device, not a night vision device. It's something far simpler than that. It's... Can you see the mirror in there? Yeah, I think you can. It's a mirror galvo. It's a mirror galvanometer made by EAW. And you can see that it's so for charge it's 10 to the minus 8th coulombs per millimeter per meter, and for amps it's 0.6 times 10 to the negative 9 amps per millimeter per meter. So this is a galvanometer, and it has basically a meter movement inside, and you can see the mirror moving around. And what happens is there's a long, thin quartz wire or something like that, or a very, very thin, hair-thin wire suspending a meter movement in a magnetic field. And when you apply a current from these two terminals, you have to look on the big camera, it will deflect the mirror. So deflection, basically, if you shine a laser beam and point it at a grid or a sheet of tracing paper, millimeter tracing paper, graph paper, and you put the graph paper a meter away from the device, a millimeter of deflection means whatever that was, 0.6 times 10 to the negative 9 amps of current flowing through the coil of the galvanometer. So an incredibly, insanely sensitive small device. And it's very, very fascinating, actually. And I had to fix it because it was very rough handled, and it actually, one of the connections to the movement was very, very broken. All right, let me just perk myself up and move the thing. Right, and I'll hide the small camera so we can see the entire device as it stands. Okay, by the way, I'm not gonna dig too deep into this thing. We're just gonna take a very, very coarse look over it. I'm gonna turn it on and show you what it does, what it's supposed to do. And we're gonna have a small chat about it, and then I'll have to also leave you I have to go to work tomorrow. So This is a Brüel and Care something, type 2305 level recorder, and it runs off of mains. It has a small little light here to light up the tracing paper, and underneath here, let me just turn it off for a second and show something really cool. Underneath here, there's a giant linear motor. It is absolutely beautiful, yes, and it was far too cheap. There is a logarithmic potentiometer. And you can see before changing the potentiometer, set a potentiometer range switch in position standby, which it was, and keep slider here. And you can see the contact for the potentiometer. One side is, I don't know exactly how it works. I'm assuming there's a wiper in there that you could barely see. I'll do a video separately on this thing, tearing it down and putting it back together and playing with it. But basically, this serves as the encoder for the stylus. And you could have different kinds of potentiometers: logarithmic, linear, higher sensitivity, lower sensitivity, etc., etc. So you could fit whatever you wanted as an input signal onto your tracing paper. And this thing is absolutely fantastic. It has Norton gearboxes for the paper speed and for the drive shaft speed. There's a drive shaft here. I'm gonna turn on the other camera so you can see the side of the thing. So if I turn it on, you can see the drive shaft is spinning, and if I hit paper forward, it made a clunk, and if I move it made the clunk because it changed gear. You can see the paper is advancing, and let me show you what happens if you... Also, we need to set this here like this, and then we can change the default position of this thing, and it's very sensitive. Like, it has a very long time constant, and it averages, and you know, it's so pretty. So there's a drive shaft speed selector with a full gearbox inside, and we'll take a look at that in more detail next time. And not only that, whoops, it's going backwards. Okay, I stopped the motor. Not only that, there's two gearboxes in here running off of the same motor, and it's so cool. Really freaking fantastic. And it's extremely heavy. I carried it around quite a lot today, and it was not pleasant. And the manual for this thing is just a wealth of information. Like, it could have signal generators and stuff synchronized to this, so you could do frequency analysis for microphones and speakers and all sorts of acoustic equipment. And yeah, it's just a Bonnie, a beauty, and a joy forever, to cite Dave from EV blog. Excuse me. Right, so I am going to do a separate entire video about this thing. We'll take a look at all the mechanics, all the electrics inside. This thing also has a chopper inside, and they actually brag about it, so you can see how cool that is. I think this potentiometer is a bit crunchy. You know? Or it's just me being dumb and not realizing that I'm actually looking at a delayed image. Anyway. But for that, I'm going to need an ink thing, or, you know, something. And it does seem to need a bit of TLC. like some lubrication maybe or something like that, because it seems to get sort of stuck sometimes, and it responds very well in certain conditions but not so well in others. So I'll see what I can do about it, and maybe we can do a video about this thing. And yeah, that's my plan in the end as well. I just want to have something like, I don't know, something very stupid like a temperature sensor or a seismometer or something like that. Like this mirror galvo and a photodiode and a laser, and do something like a interferometry setup, and have the measurements of something logged by this thing, and just continuously spitting out graphing paper with some reading on it, some arbitrary reading like vertical movement of the apartment, or something like that. That would be really cool, but it's gonna have to wait for a while, because time is time is a very precious commodity. So I think I could measure the speed of light, because I think I have enough things to make an interferometer. Well, the cats are petrified about the thing. I don't know. I think they don't like the color, but they kind of stay away from it. They usually love to crawl and climb on every other piece of test equipment that I own. I find them over the monitor, so sometimes I would find pesto on top of the monitors that I use to work. And no, let me show you what the wine from the chopper sounds like. Let's see. Can you hear it? That buzzing is the chopper for the DC. So if you put it on DC response, rectifier response, it engages the electromechanical chopper. Anyway, guys, it's been an hour and a half, over an hour and a half, and I am delighted to have had you. But I am running out of time to prepare for next week. And if you can believe it, I still haven't gone through everything that I got from the flea market. And that's good news for you, because there's a lot more stuff for you to see next time. Thank you all for joining. And I'll see you next time. Probably next time it will be on a Saturday. I think I'll have a tube tester by then, and I'll have something else. Thank you very much for joining, and see you next time. And of course, I'll have the cats. So, bye, guys.